now we're going to run the SNR, or signal to noise ratio. I'm going to demonstrate at two separate intensities so that we can see how it changes. But the first thing we need to do is set up the test. So we select the test from the list here, double click on the setup, and we have a few parameters that we need to select here. Since we're running with a visible camera, we need to set up the integration sphere, or our radiation source. So in this case, it's an integration sphere. We make sure that the table, the calibration table, is in foot-lamberts, and it's the one that's selected here. It has to be the same one, and this is usually set up at CI during integration. Output is something that is the intensity output that you can set. We're going to start at 1 foot-lambert. Offline mode, this is another option that we'll go over separately in a different session. The radiation source has to be the integration sphere, so which will be positioned behind the target wheel. So in this case, we have a motorized source stage, so we need to select the integration source. There are systems that don't have a source stage or a motorized source stage, and there's only one source and it's always the same source. But here, when you can select different sources, such as thermal or for thermal or visible, you need to select either the black body or the integration sphere, or any other source. In this case, it's read-only because, again, it's set up, it's a visible test. In CI, we set it up to the available visible source. The target we need to select is usually a square target, because we need a large area to measure the noise. But if you don't have a square target, you can also use a step target. So the square, because it's symmetrical, the step is because it's in the middle and it's a large target. It depends. We assume that the noise is the same characteristics all around the target area, so it should not matter where you make the measurement. These are the outputs of the test. We give it in two formats, one in dB and one just a signal versus over the noise, or the ratio. And we measure the noise in the background area and the noise on the target area. So that's why you have 4 different measurements, 2 in the background area and 2 in the projected target area. You can, of course, set the criteria by right-click editing the criteria. I wouldn't know what the value is here, but let's say we would put it from 1. You want to make it as tight as possible, but let's make it pretty large. This is based on your camera specifications, maybe, or through trial and error. Okay. Next, we have a set of strings these are prompts throughout the test. If you need to change them, you can double click and edit the message. Then we continue on to selecting the video input source. Again, we can use a global variable through the parameters list here. And we can select the imager, or the imager type, or the frame grabber type. Afterwards, we need to average the frames. I would start with 100 because we're doing a noise test, we need to do some sort of sampling and statistics. So I was seeing a good number between 100 to 200. You can of course see the effect by making numerous measurements and seeing and experimenting. Finally, there are two regions of interest that you need to select. One would be in the background, one would be in the target area. This is so that you can calculate the average differential signal during the measurement. The signal to noise is the average differential signal divided by the noise, or differential noise, or RMS noise that we have in the system. Once you're finished, click on the Save button, click OK, and we're done. Okay, once we've set up the parameters for the signal to noise test, we need to run the test. So we select the test from the list here, click on the Start Execution button, make sure the setup mode is on, and run. So as we see, we're positioning the source behind the target wheel, and we've selected the integrating sphere, and you can see that it's on. Then we select the target, SWIR target. Now, I just want to zoom in a little bit. You can see here the contour of the field of view, or of the target plate. This is the active area of the field of view of the collimator. Please do not use anything outside the boundaries of this, because then it's invalid. Okay, let's follow the prompt. The prompt says blue, select the ROI within the projected target. Position it within the target, and the red is the ROI within the background. Okay, and so it can be anywhere we want within this area. Click the OK button, and the measurement is performed. So this takes a while because we're doing at least 100 frames. It has to calculate, average, and we have a result here. So we see the SNR on the target area is about 40, whatever that means in dB, and it's a little bit higher in the background area because obviously in the background for a visible camera it's much quieter, there's a lot less noise there. Click on the accept. Now we're going to run it again. I'm going to set the intensity to maybe like 5, and let's see what we're going to get. So we go into the setup, set the intensity 5. OK, store, save, run. So we're just going to compare the results, see how it changes. Again, the regions of interest come up from the last run, so we don't really need to change anything. Click on the OK button. So obviously the signal to noise ratio changes, and here we've seen it grow higher on or increased when we increase the intensity. Click on the accept button, close, and now we're going to run the report. Thank you. So after we've successfully ran the SNR VIS test, we're going to look at the test summary and then create a report If we double click on the summary here, we can see the values that were measured. Again, since we had some sort of criteria on black and the white signal ratios, they failed. But those that didn't have any criteria just display measured and it's green as if it passed. We can look at the configuration parameters of the test, and we can look at the summary, which was failed because we had a failure. Now, remember, signal output was 5 foot-lamperes. Let's look at another result, which was run at a little bit before at a different value, and we see here at 1 foot-lampere. So we're going to print the test result, the summary of both test results. We're going to set the quick basket. From the tab here, we see all the tests that we ran in this session. So we can select the 2 SNR tests, click on the Create Report, use the quick basket. I'm not sure if there's an image here, so let's use a small or medium, Create Report. Okay, so we have the sum results of 2 tests. Each one ran at a different value, intensity, and of course, what I just wanted to point out was that at different intensities you get different values of signal to noise ratio. Again, we can print this to a printer, or we can save it to a PDF file.